Hello, this is going to be lesson B15, complex numbers. It's found on section 11.7 of your textbook. We're going to talk about imaginary numbers, and the definition of imaginary number basically is the square root of a negative number. Okay, so for example, suppose I have the square root of negative 25. We all know that 25 is a perfect square, or also if we do the prime factorization, it would be 5 squared. Well, 5 squared can come out of the radical as 5, and the negative sign, it will come out as letter I, which stands for imaginary unit. Okay, so basically, all we're learning here today in this lesson is if you have a negative inside or square root, the negative comes out as a letter I. So for example, on the next example, I have square root of negative 3. The negative will come out as I, and the 3 will stay because the 3 cannot come out. So my answer would be I square root of 3. Okay, notice that usually if you have a number outside, the I comes to the right of the number. If the I has a radical, the I comes before the radical. Okay, and as we're going to see on the next example here, the I goes between the number and the radical. So usually this is the standard form that you would write answers if you had a letter I. The I comes before the radical and it comes to the right of any number that is outside. Okay, so here's example letter C. We have negative square root of negative 50. So basically the negative is outside. We do the prime factorization of 50, which is 2 to the first, 5 to the second. The negative will come out, the 5 squared will come out, but the 2 will have to stay in the house, or in the radical. So the 5 comes out as 5 to the first. Remember, we have a negative outside that we need to bring here. And the negative inside goes out as letter I. And we're left with square root of 2. That's that. Okay, now let's go on to the next example where we have square roots of negative numbers and we're doing some operations such as multiplication. Okay, so for example here I have square root of negative 2, square root of negative 7. It's very important that you remove the negative first before you can multiply these two numbers. Okay, so the negative comes out as letter I, the negative comes out as letter I, and then this would be I times I equals y squared. Square root of 2 cannot be simplified, square root of 7 cannot be simplified, but because they're both square roots, we can multiply and we get 14. So this would be I squared times square root of 14 equals, well, by definition, over here, I squared equals negative 1. So if you ever have I squared, then it becomes a negative 1. So in this problem here, I have I squared square root of 14. Then I replace I squared with negative 1, and you can write your answer like this, or you can leave the 1 invisible. Alright, so let's go on to the next problem. Here I have square root of negative 25, square root of negative 25. 25 happens to be a perfect square, which you know is 5. The negative comes out as I. Second square root is also a perfect square. So the negative comes out as I, and the 1 comes out as 1, because square root of 1 is 1. So here I have 5i times I, which is 5i squared. We know that I squared is negative 1. 5 times negative 1 is negative 5. Alright, next problem, I have square root of 27, so I'll do the prime factorization, which is 3 to the third. Then we have also here negative 3, so the negative will come out as I. Now we notice that these two radicals are the same, so I'm going to put them together. So 3 to the third times 3 to the first gives me 3 to the fourth. 3 to the fourth can come out as 3 to the second. 3 to the second happens to be 9, and remember you put the number in front of the I. Okay, the next problem we have square root of negative 8 divided by square root of 2. So first thing I do is I remove the negatives, so it's very important to always try to remove the negative first. The I comes out. Square root of 8 divided by square root of 2 is square root of 4. And square root of 4 is a perfect square, so this will be 2i. Alright? Alright. So now we're going to go on to example number 3. We're going to simplify some different expressions that involve the letter I. We have to keep in mind that I squared equals negative 1. That's very, very important. Okay? And also, usually they ask us to write our answers in this format: a plus bi, which stands to, if you have any numbers without I, you put in the front, plus or minus any numbers with I second. Okay, so let's take a look. Suppose I have these two. Suppose I have this expression, and basically what I'm going to do is add these two. So basically, I get rid of the parentheses. In this case, you distribute the positive, and the positive doesn't do any change. The one time that you need to be careful is if this was a negative, because then the negative times a positive becomes a negative, and negative and negative becomes a positive. But in this particular problem, it's positive, so basically the parentheses just disappears. Alright, now that we have that, we're going to combine like terms. We have 5 and 4. They're like terms, so we're going to add them together, equals 9. And then we have 2i minus 3i, combine them together. Signs are different, so you subtract to be negative I. And basically here you're left with this because you cannot do anything else. You cannot combine 9 with 1i. Okay, so just leave it like that. Alright, the next one is going to be like a FOIL, because we're multiplying these times this. So you do first times first is 20. Then you do the outside numbers, which gives you negative 15i. Then you do the inside numbers, that gives you 8i. When you combine these two, you subtract to get negative 7i. And then the last one is last times last. 2 times negative 3 is negative 6i squared. Now remember, I squared is a negative 1. So basically I copy everything and I replace the I squared with negative 1. Negative 6 times negative 1 gives you positive 6. 20 plus 6 gives you 26. And you bring down the 7i. So as you know, I wrote in the format that they usually request. Okay? Next one. I have negative 5i times 3i. So negative 5 times 3 is negative 15, and I times I is is I squared, which we will then replace with negative 1, and then negative 15 times negative 1 gives you positive 15. Here's an example where they have a negative. Make sure you distribute the negative, so negative times 2 is negative 2, negative times a negative I is positive I. Who can I combine? I can combine 6i with I, but because I want in this format, then I need to make sure to put the negative 2 first, and then 6i plus I is 7i. Alright? Alright, let's go on to the next problems. This one, we're going to distribute the negative 2i, so this would be negative 2i times 6 is negative 12i. Negative 2i times negative 2i gives you positive 4i squared. We're going to replace the I squared with negative 1. That gives me negative 4, and that will go in the front, and then negative 12i goes in the back. Okay, a lot of students are tempted to, whenever they get a result of I squared, to do everything in their heads. I would caution you to do that, because I've seen many students make mistakes. You know, just take a few extra seconds to write the problem step by step, and you should be fine with the signs, because you need to really pay attention to your signs. Okay. Alright, next problem, we have I minus 2i squared. So what would I do? I would write 1 minus 2i twice, and I would apply FOIL. So first times first is 1. And then the outside numbers would give me negative 2i. The inside numbers will give me negative 2i. So if you combine that, I get negative 4i. And last times last, I get 4i squared. Remember, I squared is negative 1. So that makes it this as a negative 4. And I will combine 1 minus 4 is negative 3 minus 4i. Here again I have a FOIL. So first times first is 36. The outside numbers give me negative 30i. The inside numbers give me positive 30i. They would cancel. And I'm left with 5i times negative 5i, which is negative 25i squared. I squared is negative 1. So negative 25 times negative 1 is positive 25. 36 plus 25 is 61. Alright? Alright. And let's go on to example number 4, which talks about dividing. So divide and write in the form of a plus bi. Okay, suppose I have this expression here. Okay, and basically I'm starting out with this problem right here. This was not in the problem. Okay, so basically I'm asking to divide this times by this. Okay, what I'm going to do is we want to write in this format. So that means we don't want any i's on the denominator. So what we're going to do is we're going to multiply the denominator, this fraction, by the conjugate. Remember conjugate? Conjugate, it has the different sign. So it's basically the same binomial but with different signs. So basically this part here I added to the problem. Okay, in other words, the problem start out with this. I have nothing else over here. Okay, and basically first thing I'm going to do is get rid of the I on the denominator. How do I do that? I multiply it by its conjugate. 2 plus 3i over 2 plus 3i. Remember, by multiplying top and bottom by the same thing, we're not doing any changes to this fraction. Okay, alright, so we do FOIL. So first times first is 4. The outside number gives me 6i. The inside number gives me negative 6i. The 6i's cancel. Less times less gives me negative 9i squared. On the top, 3 times 2 is 6. The outside numbers give me 9i. The inside numbers give me 2i. When I combine these two, I get 11i. And less times less gives me 3i squared. Remember, I squared you need to replace with negative 1. So that's what I did. So that makes this a negative 3, and this makes a positive 9. And if you notice, 4 plus 9 is 13. 6 minus 3 is 3. And this is 11i. If you notice, there's no I on the denominator, and that's the whole idea of multiplying by the conjugate here. Okay. My final answer, because they asked me for this, a plus bi, I'm just going to break the fraction. 3 over 13 plus 11 over 13. Okay. And in class I was giving an example that because remember on the final exam you have multiple choice, so sometimes students come up with this and they break this down like this and they're looking for the answer. But remember, can I simplify this fraction? No, I can't, but I can simplify the first. So the first would become 1 over 4. Okay, so the reason why I did this extra example here is because over here they could not be simplified, so the answer stays like that. But let's imagine that the answer instead of this was this, then I would break in such a manner: 3 over 12, 11 over 12, 3 over 12 would reduce to 1/4. Okay, so if in the final exam you don't see this or this, try to see if you can reduce any of the terms, okay, or any of the fractions. Alright, so let's continue on to the example here. So I started out with this problem, and my job is again to write in this format. Okay, so first thing I need to do is get rid of the I on the bottom. So how do I do that? I multiply top and bottom by I, because that will eliminate the I. Okay, so 5i times I is 5i squared, and top is 6i. On the bottom I have I squared, so I substitute negative 1. So that means this becomes negative 5, and 6 divided by negative 5 is negative 6/5 I. You can leave your answer like that, or you can put a 0 in front, so that it would follow this format right there. A number plus or minus a number times I. And that's what we have here. A number minus a number times I. Okay? Alright, so let's go on to example number 5. Okay, this problem I'm asking to simplify or to find the powers of I here. And basically, before we do anything here, let's go over here and do some thinking here. We have learned a lot now that I squared equals negative 1. Now let's imagine I had I to the 4th power. I to the 4th power is the same as I squared times I squared, which in turn is negative 1. And negative 1 times negative 1 is positive 1. So what can we conclude? That I4 is 1. And in fact, any exponent multiple of 4 will be equal to 1. So any I raised to a power multiple of 4 is equal to 1. So let's say I have I to the 12. 12 is a multiple of 4, so therefore I equals 1. I to the 24th, same thing, multiple of 4, so equals 1. I 48th, 1. Alright, now that we have that in mind, any number raised to a power that is multiple of 4 is 1. I'm going to come back here and we'll try to simplify this I to the 11th. Okay, basically what we're going to do is we're going to manipulate this exponent. We're going to break down I to the 11th as two numbers. One of the numbers I wanted to make sure that is the number multiple of 4 closest to 11, but not bigger than 11. So what is the numbers closest to 11 that is a multiple of 4, but it's not bigger than 11? Well, that number will be 8. So basically I'm splitting 11 as 8 plus 3. Okay? Also, I to the third power. We can also rewrite I to the third power as I squared times I to the first. Now why do I want to do that? Well, the reason why I want to do I to the 8th is because 8 is a multiple of 4, so therefore I to the 8th is 1. I to the second, we learned that is equal to negative 1. So basically I'm able to substitute this as a 1, this one as negative 1, and this one stays as I. So 1 times negative 1 equals negative I. So in other words, I to the 11th can be simplified as negative I. Alright, let's look at example number letter B, I to the 40th. Off the bat, I see that 40 is a multiple of 4, so I know that I equals 1. Alright, and here I put like a little reminder because it was the next page that I squared equals negative 1 and I multiple of 4 equals 1. Here, 50 is not a multiple of 40, so I'm going to break it down. I look for the number multiple of 4 closest to 50. Well, that would be 48. So 48 plus 2 is 50. And that works wonderful because 48 is a multiple of 4, so it's 1. And I squared is negative 1, so my answer is negative 1. Suppose I have a negative exponent. Anytime you see a negative exponent, flip it. So I flip I to the 10th power. Now break it down with a number closest to 10, and that is a multiple of 4. Well, I to the 8th, I to the 2nd. I to the 8th is 1, I to the 2nd is negative 1. 1 times negative 1 is negative 1. 1 divided by negative 1 is negative 1. Okay? Alright, so this concludes lesson B15, and here are the practice problems followed by the the exercise set in the textbook. Please remember that yes, there's a lot of problems here, but some of these problems are very easy to do and they take very few time to do them because all you're doing is changing I and working with I. Okay? Alright, thank you very much for your time. Have a wonderful day. Bye-bye.